I'm not geneticist, but I try to multiply the animal that you select. So I will talk about the future that we have today, the technology we have today to multiply the animal that you select and try to have a high reproductive efficiency in the farm. So I'm a worker here at São Paulo University. We have a facility, we have farmers, but we work in strong collaboration with the beef and dairy farmers in Brazil and with the labs that multiply animals, that multiply using artificial insemination or embryo transfer. So we work in our lab with these animals, Bos indicus for milk, for beef, Bos indicus Taurus for milk and beef, and some buffaloes also that produce milk and buffalo and beef in Brazil. So, of course, you know that you are selecting here, you have a high specialized research to select the animals, but we need to the diffusion of these animals is very important, and so we increase the productivity according to the biotechnology we are using today. So we have mainly in the world two strong biotechnologies. One is artificial insemination and another is the embryo transfer. I just show you the numbers in the world about the AI in dairy and beef. So we know that AI is a powerful method for gene dispersal and all of the most artificial technology in the world that we are using. So I will start using the data from the number of AI in the world. Look here, this is dairy and beef, but we are doing around 22% of the cow in reproduction are artificially inseminated in the world. So we need to improve. We are improving, but now it's a little through the last year. We can see here that we are not improving so high the number of artificial inseminating in the world. Of course, we are doing more in dairy than in beef, but we need to improve the use. Of course, you select the animal, the AI will be a strong possibility to spread genetically high genetics in the world. But as you know, it's so difficult to introduce the AI in the farmers because we have to understand the estrous cycle. Mainly the estrus detection is the mainly problem in the artificial insemination efficiency. So when we use natural service, we can have a high reproductive efficiency, but genetic gain, of course, is decreased. When you use AI, we can have high genetic gain, but when we are using estrus detection, the reproductive efficiency decreases. And today, as you know, we have a new technology to improve both the number of cows produced by AI, so high genetic animals, and high reproductive efficiency. We can put together these both situations like that. I think that's very important for your program for selection animals. Just to understand what we are trying to show you. So if we compare in the same situation, natural service or a system that we use in technology, we can induce the ovulation at the same time of a large animal, and we use here a semen of high genetic animals. So at the same day, at the same moment, compare the natural service with fixed time AI. You can see here that using fixed time AI, we improve the efficiency. We can decrease the interval to establish the pregnancy according to natural service, and we have a high efficiency compared to natural service. So today, we can use it by using the artificial insemination with the animal that you select with a high efficiency more than natural service. So I think that's very important to understand. Of course, I will not discuss with you, but we today synchronize with all these bioidentical hormones the ovulation to do this system. So today, if you have a female that produces an embryo with high genetic animal, we can synchronize the recipient. If you have a male with a high genetic value, we can do AI with high efficiency in the farm. This is the message for you. This kind of a protocol for synchronized ovulation was developed in the last 30 years in all the world. We have today a strong system for that. But just to show you that today is arriving in our market, so the recombinant hormones. Today we are using recombinant hormones also for as example. We have an important treatment to induce ovulation, mainly in an estrus animal. And look, that is arriving this recombinant hormone producing the labs, bacteria that we introduce the genes to produce the recombinant hormone like the ECG. We present this in the last ICAR that was in Bologna 1 month ago. So using these technologies, look at the importance of this biotechnology that have high efficiency, reproduction efficiency in the Brazilian artificial insemination model. Look that in 2002, we are doing only 6% of the beef and dairy cows are artificially inseminated. Look at that now in 2021, you are arriving 23%. We have 4-time increase, so this is very important for your genetic problem. So today we have a technology to improve the number of animals artificially inseminated. You are artificially inseminated 3.4 million cows, and now 18 million cows are artificially inseminated in Brazil today. And this, to understand what we are discussing with you, look that this is the number of semen that we commercialized in Brazil. Look, we are arriving 28 million doses in this situation. 20 million doses was artificially inseminated. But look that in 2002 as only 7 million. So a huge increase. And look here, in 2002, only 100,000 animals are artificially inseminated using the pixel time AI. And now is 93%. So today the market accepts this technology that has a high efficiency to multiply with them. So just to talk a little more about embryo transfer, is this just so you understand how is the embryo transfer important in the world and in Brazil. Just show you, this is the data for ITS, the International Embryo Technology Site. This is the new data from 2020 for João Viana that works in collaboration. But look that we are changing the model to produce embryo in the world. Look that here in 2002, 90% of the embryo was produced with a technology that we know in vivo. Now, changing completely in 2016, 75% of the embryo in the world are produced in vitro. So if you would like to multiply your animals that high genetic value, probably we are using today in vitro embryo production, that we collect those sites and we do the maturation and the fertilization in the lab and transfer the embryo after development 7 days after. It's a completely change. In Brazil, we changed the market for in vitro 11 years before in the world. So we start to develop this in vitro embryo early in the world. So this is the number in the world. We are transferring around 1.5 million embryos. In Brazil, around 700,000 embryos per year. Half of the embryos in the world we are transferring in Brazil, in the cattle, and 97% is in vitro. This is the market using also fixed time AI protocol. So the recipients today are synchronizing. A group of recipients can receive at the same time the embryos with high efficiency. This is the model. So we developed a model to produce in the lab the embryos, but just to show you that what you have with a news in the world today, or not a news for probably for someone, but trying to decrease the generation interval to increase the genetic gain. What we are doing today, the velogenesis. So we are not a new 60 years ago, some research published about the velogenesis, but what's the velogenesis? Today we can produce embryos for young animals. Young animals, this is the ovary for a young 2 months, 3 months calves that have more than 100 oocytes here that we can collect to produce embryo in the labs. So this is how we can do that. This is São Paulo University, our lab. This is a young animal, 1 month, 2 months, that we try to superovulate them. We collect the oocytes today for Taurus, for Indicus, for Holstein, and we collect the oocytes and we transfer to recipients. So this calves here was produced, the mother has 2 months. So we can decrease the the interval between generation for normally 3-4 years for 1 year. So of course we accelerate the genetic length in the model. This is again in São Paulo University. The mother of this calf here that we produced was 2 months old. So just to show you that's possible, this is the buffalo, this is the donor, this is the donor 2 months old, and this is the calf that born from donor that had 2 months old. So the intercalv interval is 1 year, not more 3 or 4 years. So accelerating the process. And now to produce these calves, to produce these embryos, we are using also recombinant hormone that is arriving for superovulation. This is a paper that we published now last week in the World Uriatic Congress that was in Madrid. That show you that we can use recombinant hormone. We can improve the number of follicles in the ovaries of the animals, not only the follicles, but of course we can improve the quality of the site. We can improve in 70% the amount of embryos that we can produce per procedures using these possibilities. So in here, we also improve the pregnancy rate of the embryo that we transfer when we use this molecule as a molecule to superovulate, improve the oocyte quality, improve the number of embryos per OPU of these high genetic animals, and conception rate in the recipient. So this is the knowledge that we have today about the new molecules and the possibility we have to improve also the reproductive efficiency of them. And as you know, then, of course, we need to improve the genetically. We can have selected animals that produce low carbon, but we can also understand that if you have a recipient of cow using artificial insemination, if we improve the conception rate in our programs, we can reduce the necessity of the land, the water, and the carbon emissions. So we need to put together with your selection for high genetic animals, also high efficiency of the animals that are using artificial insemination or embryo transfer. Try to improve decrease the environmental impact of the animals. We are studying this now. We have a group that are trying to show the best of the put together the genetic improvement and the reproductive. So this is the conclusion. Today you have assisted reproductive technology to introduce in the farm, in the program, to multiply the animal that you are selecting with high efficiency today. as an artificial insemination program or embryo transfer program. Of course, the AI, if you have a high genetic animal, beating animal, you can collect the semen in using the farm with the possibility to have a high efficiency. The embryo transfer also, today, we have a high technology to use embryo transfer. We can produce embryos for high genetic animals or for very young cows that accelerate your program for genetic improvement. And this technology here, the issue synchronization, helps a lot to have a program, an efficient reproductive program in the farm. Okay, just to take acknowledgement for my groups of master and PhD students, and for you for inviting me, trying to show you what you have today in the world to multiply the animal with high genetic selection. Thank you very much.